Hi folks, we're going to take a look at these solutions to this position, velocity, and acceleration worksheet. Okay, so number one, we're given the graph of a velocity function. Okay, so keep that in mind as we're answering these questions. This function represents the velocity of the object and not the position. Okay, so here velocity is in meters per second, so we can assume that time here is given in seconds. So this is meters per second in the y-axis and seconds in the x-axis. Okay, first thing they ask us is for what time or times is the particle moving in a negative direction, and justify. Well, we saw that moving in negative direction means that the velocity is negative. Okay, so we need v prime at t to be less than 0. Okay, so this is our justification. Now what we need is to find those times, and we see that it starts being negative at around 3.3 seconds till 6 seconds. Okay, then it's briefly at 0, and then it's negative again. Okay, so our answer here is 3.3 seconds to 6 seconds. Okay, and then union 6 seconds to 7 seconds. Okay, and there's our answer for that one there. Okay, next question. What is the particle's highest speed? Justify. Okay, so again, our justification is that the speed, okay, is given by the absolute value of the velocity function. So when we're talking about speed, we don't care in what direction the object is moving. Okay, we just want to know how many meters per second is it moving. So it's the absolute value of the velocity function, and we can see here that while when the velocity is positive, the highest speed it reaches is 4 meters per second, but here when we look at when the velocity is negative, the highest speed it reaches is 5 meters per second. Okay, so the speed, sort of the highest speed here is 5 meters per second. Okay, since that's the largest value of the absolute value of the velocities given. Okay, so it says here for what time or times is the particle stopped. Okay, now when we say stopped, we have to remember it might just be instantaneously. So here we're looking for where the velocity is equal to 0. And here we see that it's equal to 0 only at 2 points. Again, at that point around 3.3 and at 6. Okay, so here when t is 3.3 seconds or 6 seconds. Okay, so we got two answers there. Now it says for what time or times is the particle speeding up and slowing down. Okay, so let's keep in mind what we need to show in order to show that it's speeding up. Okay, in order to show that it's speeding up, we need the acceleration and the velocity to have the same sign, and it's slowing down when the velocity and acceleration have opposite signs. Okay, so let's take a look here. So in this interval between 0 and 1.5, we see that the velocity is positive, and the acceleration, which is the derivative of the velocity, will also be positive. Okay, so here we see it makes sense that it's speeding up because the speed is getting larger. Okay, so let's make ourselves a little chart. So we'll put speeding up. Okay, and here as our justification, we know that we need V and A have to have the same sign. Okay, and then our second will be slowing down. And here we need V and A have to have opposite signs. Okay, so we saw speeding up, okay, as in the speed is getting larger when the velocity and acceleration have the same sign. Because again, this is a straight line that's moving upwards, so the derivative is just going to be some constant positive value. So here we have between 0 seconds and what is that? 1.5 seconds. Okay. Now here between 1.5. Now here I'm using a closed interval. I'm not exactly sure whether at that point there, well, we can't put at 1.5 there because the derivative doesn't exist because we have a corner, so we're not going to consider what happens at 1.5. Okay, now what's happening between 1.5 and 2 seconds? Well, here we see the velocity is still positive, but the derivative, the acceleration, is 0. Okay, and it makes sense that the speed is not actually increasing or decreasing, it's staying the same. So we don't expect there to be anything going on in terms of speeding up and slowing down in that interval. Okay, now let's take a look at 2 to 3.3. Okay, and here we see clearly the object is slowing down. The speed is getting smaller. Okay, and we see that the velocity is positive. Okay, because it's still, remember this is the velocity function, is still positive, but the acceleration is negative since the slope of the tangents, okay, just a straight line, are going to be negative in this whole interval. So it's going to be slowing down between 2 seconds and 3.3 seconds. Okay. So let's take a look now in this next interval, and we see now, remember this is the velocity function, the speeds are increasing. Even though velocity is decreasing, the speed, which is the absolute value, is increasing. So it's speeding up, and we see, as we expect, the velocity is negative and the acceleration has the same sign. Acceleration is also negative. So not surprisingly, in this interval of 3.3 seconds to, so this looks like to be about 5 seconds, we're in the speeding up category. Okay, so even though the velocity is decreasing, the speed is increasing. Okay, and then let's go to 5 to 6. We see the velocity is negative, but the acceleration is positive because the slope, the tangents here, the derivative is going to be positive here, and it makes sense that it's slowing down. The speeds are getting smaller. So here we will put from 5 seconds to 6 seconds. Okay. And lastly here, between 6 and 7, we see that the velocity and the acceleration are both negative. And if we look at the graph and think about the speeds are increasing, so it is speeding up, velocity and acceleration have the same signs. Okay? So here between 6 seconds and 7 seconds, the object is speeding up. Okay, so that's it for number 1. Let's take a look now at number 2. Okay, and they give us the position function this time of some vehicle. Okay, and they want us to determine the intervals where the vehicle is speeding up, slowing down, and when it's moving toward or away from the origin. Okay, so let's recall. So we already saw speeding up, slowing down. We have to show that velocity and acceleration have to have the same sign for speeding up, different signs for slowing down. And it's very similar for whether it's moving toward or away from the origin. If the position and velocity have the same sign, it's moving away from the origin, and if they have opposite signs, object is moving toward the origin. Okay, so first thing I'll do is I'll calculate the velocity and acceleration. So here we have s at t is equal to t cubed minus 2t squared plus t. And since I'm going to need the sign of this function, I'm going to try to factor this right away. Okay, and pretty easy here. They all have a common factor of t. So t squared minus 2t plus 1. And we could keep going. T times t minus 1 squared. Okay, so now we'll find the velocity. Okay, now I'm going to find the derivative using that original expression. So here I have 3t squared minus 4t plus 1. And again, I'm going to need the sign of the velocity. So I'm going to factor this out here, and it does factor out nicely. 3t minus 1 and t minus 1. Okay, and then the acceleration. Again, I'll go back to this original one to find the acceleration. So here we've got 6t minus 4. Okay, so these are all polynomial functions. So in order to determine their signs, all we have to do is draw ourselves a little graph with the zeros and then use what we know about the polynomial function in order to figure out when it's positive or negative. Okay, so let's start with the position function. Okay, and I'm only interested in values of t greater than 0. Okay, so I look at this here and I see that the zeros for the position function occur at 0 and at 1. Okay, so those are my only zeros. Okay, so I can either test these two intervals, Okay, or since these are the only two zeros on the function and it's a cubic function with a positive leading coefficient, I know that my function would look like this. It would start at negative infinity, come up, go through 0, and then it would just touch 1 because 1's a 0 of order 2. So it would look something like this. So here I can see that the position is positive between 0 and 1, and it's also positive between 1 and positive infinity. I don't care about this part where the function's negative. Okay, so that's pretty good. Let's now draw one for the velocity. Okay, again, and what I'm going to do is I'm going to make sure that I keep everything consistent as I go vertically so I can make my comparison more easily. Okay, so now here I have a 0 at 1, but I also have a 0 at, well, when I solve this for 3t minus 1 equals 0, I get 1/3. So here I also have a 0 of 1/3 for the velocity. Okay. Now this is a quadratic function with a positive leading coefficient, so I know that my graph would look something like this. So I know it's going to be positive to the left of 1/3. It's going to be negative between 1/3 and 1, and then positive again. Okay. So from this here, I can now make the determination of moving away or toward the origin. Okay, so we'll do that here. Okay, so moving away. Let's take a look at moving away. Well, we said it moves away when the position and velocity have the same sign. So here we see that we have the same sign. Okay, from 0 to 1/3, they're both positive. Okay. So moving away, we've got 0 seconds to 1/3 seconds. Okay, and I should, okay, I'll do the other chart later on. And let's see, is there any other place where in this interval here, they have opposite signs, so we don't need that. But from 1 onwards, we see that they're both positive. So again, from 1 second to positive infinity, since there were no conditions given on when this stops. Okay, that's what we'll assume. And now we'll have moving toward the origin. Okay, and we already saw where they would have opposite signs between 1/3 and 1. Okay, so 1/3 seconds to 1 second. Okay, and so we've done with that part of the question. Let's now put in the acceleration function. Okay, again, only care starting at 0. Okay, and here we see that if I solve 6t minus 4 equals 0, we get 4/6, or 2/3. Okay, so 2/3 is the only 0 for this linear function, and since the leading coefficient is positive, we know it's going to be a line moving upwards. So in other words, it's negative in this interval, positive in that interval. Okay, so from here now we can determine when it's speeding up and slowing down. Okay, so here, if we want to look at speeding up, it's when they have the same sign, velocity and acceleration. And we see here, if we kind of draw a line here and a line there, okay, we see that they have the same sign. They're both negative, okay, in this interval here, from negative 1/3 to 2/3, they're both negative. Okay, so here we've got from 1/3 seconds to 2/3 seconds, they're both negative, hence it's speeding up, and we see that from 1 onwards, they're both positive. So again here, from 1 second to positive infinity seconds, we've got the same sign, so they're speeding up. And let's look at slowing down. Well, here, from 0 to 1/3, they have opposite signs. Okay, 0 to 1/3, they have opposite signs, and they also have opposite signs from 2/3 to 1, because the velocity is negative and the acceleration's positive. So from 2/3 seconds to 1 second, they have opposite signs. Okay, and this is how you can solve this problem. So again, remember the relationships that you need to show in order to determine all these scenarios, and doing this graphically is a great way of keeping everything in order.